Hello everyone, my name is Cory Graham. I'll be presenting the security policies for GreenPace that I've been working on. So the first thing we want to go over is the defense in depth. Um, Kind of an overview of what defense in depth is a multi-layered protection for our systems, meaning that we are going to have multiple levels, multiple different versions of protections to make sure that hacking or unauthorized access is prevented on the most common grounds. So the purpose of the new security policy is to address just those broad ranges of those vulnerabilities and protect GreenPace's system overall. In my previous documentation, I identified 10 standards that we should take into consideration. And here you can see those standards ranked from priority to low priority. Um, we will mostly need to focus in on the priority and likely first to make sure those threats are addressed promptly. And once we have those threats addressed, we can move more toward the low priority and the unlikely situation. This indicates, where our focus should be and what steps we should take. Here we have the 10 principles that we need to consider when developing protections. Um, Typically, whenever we implement some sort of protection, and they will fall under one of these categories. We are either going to validate input data, we are going to heed compiler warnings, we're going to look at the architect and design security policies. Importantly, we also need to keep it simple, do default deny, meaning that we're going to do the have each user only have the minimum amount of access necessary. We're going to adhere to the principles of least privilege, sanitize data sent to other systems, practice defense in depth, which I already explained, use effective quality assurance techniques, and adopt a secure coding standard. Listed under some of these principles are the standards I have come up with, and this kind of makes it a little bit easier to understand what the main focus of each of them are. I have also taken the time to rank my coding standards in order of the most important, the most priority, to the least priority. And I've also included off to the side their standard code. So first and foremost, we really need to make sure we sanitize inputs before passing them into SQL queries. This is going to help us protect against SQL injections, giving unauthorized access to our system. Secondly, we do not store an already owned pointer value in an unrelated smart pointer. Third, we guarantee that storage has sufficient space for character data and a null terminator. This will prevent buffering. Do not access an object outside of its lifetime. Never qualify a reference type with a constant or volatile. Honor exception specifications. Obey the once definition rule. Use assertions to catch logic errors. Close files when they are no longer needed. And lastly, ensure your random number generator is properly seeded. Here we have our encryption policies. Now these encryption policies will protect information while it's not being used, while it's being transported to the user, and while it's being used by the user. So our encryption at rest, it protects stored data by encrypting it on disks, databases, and backup to prevent unauthorized access. It's used on files, databases, cloud storages, and backup media. Encryption key control access, think of cold storage. Encryption in flight protects data while it travels across networks by converting it into unreadable ciphertext. This is used whenever data moves between systems, devices, or services. Encryption in use protects data actively being processed in memory or CPU by applying techniques like secure enclaves used in environments handling sensitive computations, such as confidential computing or protected memory areas. GreenPace also has a AAA policy, which which is meant for the users. Now, with our users, we need to authenticate them, authorize them, and keep them accountable. The authentication confirms the identity of the user before allowing access. This requires unique login credentials and multi-factor authentication. Think of your password, your username, and any other levels of security. This ensures that only authorized individuals can access the system and database. Authorization. This is also part of the principles of least privilege, controlling what authenticated users are allowed to do. We want to allow them the minimum necessary access. This enforces the least privilege, like I just mentioned, meaning users can only access the minimum amount of information necessary to perform their job. This helps prevent leaks by preventing people's unnecessary access. Accounting, recording and monitoring users' activities for accountability, logging users' login attempts, failed and successful, track all changes to databases, including who made changes and when. This ensures traceability and support investigations into security incidents. I've also taken the liberty of including some unit tests. For example, this one is to verify the max size. Now, if you look over here, I have defined different sizes of, um, excuse me, of the collections. So we go and cycle through each collection under having the maximum capacity of 0, 1, 5, and 10. And as we go through, we're able to see and confirm that each collection does match up to its max size. Similarly, we also have a test to verify capacity size. What we're checking for is that the capacity is greater than or equal to the sizes that we have set out, 0, 1, 5, and 10. And as you can see, as the test goes through, we're able to test to see whether or not it follows those rules. We're also able to test whether if we try and access empty vectors, will an exception be thrown. This last test is also another error throw. What we're testing for is if we try and access something that is out of the range. When the range is set to 5, we try and access something at 7, does an error exception get thrown? Here we have the automation summary. In this diagram, you can see that the DevSecOps travels back and forth between pre-production and production simultaneously. This is to help us monitor the project at various steps. Here on this diagram, you can see what different phases of the DevSecOps and what they stand for. The DevSecOps pipeline is constantly evolving and developing system that integrates security throughout the entirety of the development lifecycle. Here we have some tools that we can use to help us in these endeavors. Throughout my research in the coding standards, there's Osprey, CPP check, and Parasoft, and C++ test. Now, with these tools comes various risks and benefits. Some of the pros is that we catch errors and bugs earlier, we make corrections happen sooner, and it prevents more possible errors in the future. This will save us money in the long run and create a more secure system. The cons, however, is that these systems do come with a level of complexity that it will take time to understand and correctly implement. We will take more of the costs up front, meaning that we may not see savings for a small amount of time. And it will take time to learn and train people on these systems. But once we have all these covered, I do believe that the pros will far outweigh the cons. I do have some recommendations for us moving forward. I believe that we need a incomplete incident response procedure. The given standards are not a catch-all for every issue. Many additional issues exist and may need to be added to the standards in the future. We should have employees keep records of all errors, bugs, and vulnerabilities to make the documentation simpler. With future advancements, technology and language, they will update, they will implement new standards, and old standards may become obsolete. There's no real way of knowing what will happen. Development teams should take time to familiarize themselves with changes and occasionally check standards to make sure that they are still the best ones for green space. In conclusion, I believe that we should really fixate on these 10 coding principles. We also need to be able to enforce all of our encryption standards and also to make sure that the AAA standards are also upheld. This will ultimately keep the system more safe and prevent any unauthorized data accesses.